Alright, here we are again, continuing on with notes lesson 9.2. We are now in the third and final part of solving quadratic equations using square roots. So we are solving quadratic equations and we're using square roots. And what I'd like to do now is go through some examples. So this is it for the notes. This is the third video and I will go through some examples. Alright, number 1. If you had 9x squared minus 35 equals 14. Now, it used to be that you would use the factoring method. So you would put everything on one side and you'd set it equal to 0. So you'd subtract 14 from both sides, which would give you 9x squared minus 49 equals 0, because you'd have to subtract 14. And then hopefully you'd notice that this is a difference of two perfect squares, and so you'd factor it into two binomials, 3x plus 7 and 3x minus 7. And then you would take each one of these quantities and set them individually equal to 0, because one of them has to be 0. Since you're multiplying and your answer is 0, one of these quantities has to be 0. So then you'd figure out that x would either equal negative 7/3 or positive 7/3. So that's the old way, that's the factoring method. So now let's try it the new way. Okay, so I'm going to do the same problem and I'm going to try it the new way. Alright, and the new way is you isolate the x squared. So you get x squared alone. So I'm going to add 35 to both sides. And I'm still trying to get x squared alone, so I'm going to divide by 9. Divide both sides by 9. And then, this is something new, you're going to take the square root of both sides. So to undo squaring, to get rid of squaring, you take the square root. And you have to do it to both sides. And what you would get would be x would equal plus or minus, that's the part most kids forget, plus or minus. And on this one it would be, let's see here, the square root of 49 is 7 and the square root of 9 is 3. So it would be plus or minus 7/3. So x would either equal positive or negative 7/3, which is what we ended up getting the old way. So the old factoring method is great. This is a new method. Notice we get the same answer, positive or negative 7/3. Alright, so why are we learning this new method? Great question. Let's do another example. Alright, so here's the next example. Example number 2. Let's say you had 4b squared minus 5 equals 2. Okay, the old way, we would set it equal to 0. So let's subtract 2 from both sides. If you subtract 2, you get 4b squared minus 7 equals 0. And then you try to factor. But you can't factor this. It's not a trinomial, and it is a difference, but these both aren't perfect squares. This is a perfect square, but 7. Okay, so factoring doesn't work. So let's try the new way. So same problem. 4b squared minus 5 equals 2. And let's try the new way. The new method is you need to get the b squared isolated. So you need to unwrap this. So the opposite of subtract 5 is add 5. So you're going to add 5 to both sides. That gives you 4b squared equals 7. And then divide by 4 on both sides. And b squared equals 7/4. And here's the new step. The opposite of squaring, just like here, the opposite of subtraction we added. The opposite of multiply is divide. The opposite of squaring is take the square root. So that's new. And the square root of b squared is actually just b, because b times b gives you b squared. And here the square root is 7. I don't know the square root of 7, so I'm just going to write square root of 7. And then I do know the square root of 4. The square root of 4 is just regular old 2. Oh, wait. It's not square root of 7 over 2. It's actually that b could equal plus or minus, right? So this could be plus or minus the square root of 2. Let's write that a little neater. So b could actually equal positive or negative the square root of 7 over 2. So you get two solutions. Two solutions. All right, just two more examples. So this is example number 3. Yeah, example number 3. So this is a little different. 2 times the quantity m plus 5 squared equals 20. All right, let's try the new method. Let's get the squared item isolated. So this is what's being squared. Let's isolate that. Right now it's being multiplied by 2. The opposite of multiply is divide. So I'm going to divide both sides by 2. I'll have the quantity of m plus 5 squared. And when I divide both sides by 2, that gives me 10. Right, something's being squared. The opposite of squaring is take the square root. And do that to both sides. When you take the square root of something squared, like m plus 5, that'll leave you with just m plus 5 equals, and the square root of 10, I don't know the square root of 10, so it'll be positive or negative the square root of 10. And I can't really break 10 down. It doesn't have a perfect square factor. Okay, so this leads to actually two things. So m plus 5 equals positive the square root of 10, or m plus 5 equals negative square root of 10. And then you solve each of those, okay? Because it could equal positive or negative. So one more step here. Subtract 5 from both sides. When you subtract 5, you'll get square root of 10 minus 5. And typically they write that as negative 5 plus the square root of 10. Because you can't tell sometimes if you write sloppy, does that square root end over the 10 or does it go all the way? So we write that last. Or, if we go over here, we subtract 5 from both sides. Negative square root of 10 minus 5. But let's write that a little neater. Negative 5 minus the square root of 10. So those are your two roots. This is one of your solutions, and this is another one. So it does cross the x-axis at two spots. All right, we'll do one more example. So here it is. Last example. You could have 5x squared plus 12 equals negative 8. 5x squared plus 12 equals negative 8. Okay, let's try the new method. Isolate the squared term. So subtract 12 from both sides. And then divide both sides by 5. And then to get rid of a squaring, opposite of squaring is take the square root. Okay, wait a second here. I can't take the square root of a negative. I cannot take a square root of a negative, so this one would have no solution. So this parabola does not cross the x-axis. All right, I hope this is helpful. Good luck.